hello to everyone on the receiving end of this recording. Today I have the pleasure of talking about some fascinating animals, specifically the Argentine ant. Before I get into that, I want to properly introduce myself. My name is Tobias Moiner. I am currently a first-year PhD student in the Rivera Lab here at UCR. I am currently interested in the foraging behavior of the Argentine ant and how this behavior influences the larger ecosystem that they live in. Here is a brief overview of the following presentation. I'm going to talk a bit about the ant colony, their dominant form of communication, their foraging abilities, and the insect and ant mutualisms that can commonly be found. So the Argentine ant is native to South America. However, via unintended human transportation, this invasive pest is now found on 6 continents and several oceanic islands. The introduced ant colonies are believed to have formed from only a few queens and workers. Because of this, most introduced Argentine ant colonies come from a very closely related ancestor and are thus seen as being related to one another. As such, they act as a large super colony in their introduced range. In theory, and in some instances, ants from one distant nest can be relocated to another nest and they won't fight each other. They'll actually cooperate with one another. And this is even the case when these two nest sources are separated by sometimes hundreds of miles. There is some debate about the idea of a super colony, so I won't spend too much time on it. But the big picture is that the ant colonies are massive. To put this into perspective, there was this 19-acre citrus orchard in Louisiana, and they reported trapping over 1,000 gallons of Argentine ants. And this was only within a single year. And within those 1,000 gallons, I think they reported trapping something like 1.3 million queens. And in this picture here, you can actually see the queens. They're much bigger than the workers, which is shown in the back. And the picture on the lower right shows an ant with their brood, which is the larvae. The colonies for the Argentine ant, they typically have multiple queens and many brood and even more workers. And these ants will spread in a process called budding, where queens and few workers will branch out from their own nest and they'll form a brand new colony. And interestingly, every spring, the Argentine ants will mass execute up to 90% of their queens. And the prevailing theory on this is that these ants will kill off the less productive queens. And this allows for, more queen production. And it also allows for a reduction in this queen pheromone, which seems to help the development of the larvae. The ants require a mixed diet of carbohydrates and protein. The protein is essential for the proper development of the larvae and the reproductive queens, and the carbohydrates are mostly utilized by the workers. Primary form of communication used by the Argentine ants, and most ants for that matter, comes from the use of different chemicals. The super colony idea has been studied and found that the particular cuticular hydrocarbon makeup, which is essentially the smell of the ant's exoskeleton, is similar between cooperating nests. So chemical recognition helps the ants determine if something is family or if something is enemy. And ants have also been known to excrete a very irritating substance, which is shown here in the picture, and this communicates to intruders to stay away. The other notable form of communication used by the Argentine ant is the use of a trail pheromone. When a forager ant finds a delicious food source, on the return trip to their nest, they will deposit a trail of pheromone that the other ants can follow. This trail is reinforced as more and more ants follow the trail and deposit their own pheromone. In this picture here, which was originally a video, but due to technical difficulties, I won't be able to play it, or maybe it will try. Basically, it illustrates that as these ants are walking and foraging and they find this trail pheromone, they themselves will walk on it. And if they find a food source at the end, on their return trip, they will deposit more. And this video is just showing that as the intensity of ant movement on a particular trail increases, the color, which indicates the paths, gets darker and darker and darker. And the formation of this trail becomes very defined at the end of this 2-minute video. So the other thing I want to talk about is the foraging activity of the Argentine ant. So the Argentine ants, they're very effective foragers. Imagine being a small ant and you have to navigate the environment of something very complex. And in this picture here, this is a picture of a pretty mature citrus tree. And Argentine ants forage on these trees all the time. And it's pretty amazing that these ants are able to navigate these trees and then return to their nests. And some amazing research done here at UCR, they actually found that not only are the ants able to forage on these trees and then return to their nests that they originated in, they're actually able to return to that exact branch the following foraging trips. I'm not sure how many left turns that would be, but with a tree canopy as complex as something like in this picture, this is truly an amazing feat. Furthermore, in the search for food, many Argentine ants will form mutualistic relationships with many sap-sucking hemipteran insects. Honeydew is the sweet byproduct that is produced from sap-sucking insects. Once found, these ants will almost farm these insects by protecting them from any other insect that might want to harm their delicious food source. And because most honeydew producing insects are an unwanted pest, ants are largely seen as a significant hindrance to agriculture because of this behavior. Several studies are coming out now that are starting to show some of the learning capabilities of the Argentine ant. Ants have a collective and individual memory as to which insects are best eaten and which insects are best farmed or tended on. This is a pretty interesting area of research, and it's going to be really interesting to see where it develops and how it continues to unfold. And this actually shows the Argentine ant finding a different foreign insect, and it identified it as a pest, an enemy. And you can see it's starting to kill it and consume it and bring it back to its nest. And this little black foreign insect, this was actually a Tamarixia radiata, which is an important biological control agent of citrus because it preys on these yellow insects, which are the Asian citrus psyllid. And fortunately to these psyllids, the ants were here to protect them. But unfortunately to the farmers, the Tamarixia are pretty expensive. The YouTube video is right over here because the first one wasn't able to work, unfortunately. The site fidelity paper, many of these photos came from Alex Wild, and his website's up here. He takes some pretty amazing shots. And then some of the biological information is cited down here below. Thank you for your time.